Okay, so continuing on this problem. Sorry, my video got cut off. We've done questions 1 through 3 already. And then so now they're coming to this ball going up a ramp modeling problem. You can pause and see the previous work there. But now they come to question 4. It says traveling at 7 centimeters per second in 1 second, how much does the height of the center of the wheel increase? So they want to know in 1 second, how much does the height increase? Well, in 1 second, it's going to travel up this 7 centimeters. So this is going to be 7 centimeters, and the height here is going to be the value that we're trying to look for. That's how much it's going to increase in 1 second. And this is going to keep the same slope as it continues up. Then from here, it'll be the same, like slope. And we'll see that same, well, I don't think I'm doing a very good job, but like it's going to continue to go up with that same slope because it's moving up. And you can see this is steady slope that we're going up right here. So I need to figure out what is this side of this triangle. So to draw it bigger, to solve this problem for question 4, the increase in 1 second will be this value y and along the height here of this triangle. And how are we going to find y? Well, one thing that I can notice with this triangle is I know this angle here. We can find that angle. That angle is, because we have the opposite side of that angle and we also have the hypotenuse. So we could say sine of this unknown angle, we'll call it theta, is equal to the opposite side, 300, over the hypotenuse, 630. So if I do an inverse sine of 300 over 630, then I can find that angle. And if I know that angle, we're thinking, where am I going with this? I could find the missing side y, because once we know this angle, then I will have, I can use a trig function to solve for it. So I'm going to do sine inverse of 300 over 630, and that gives me this 28.437. I'm going to keep it out to a lot of decimal places. Just I don't know how accurate. They may want this really accurate, so I'll just write here though 28.43, but I'm going to keep all the decimals in my calculator when I calculate this. Okay. But to find this missing y, I can just write, well, now I have the opposite side and the hypotenuse again, the new hypotenuse with sides only 7, so it's going to be sine of 28.43 is equal to the opposite side, which is y, over the hypotenuse, which is 7. Now I just multiply both sides by 7. and this will give me y. So I'm going to say sine of this answer times by 7, and I get this 3.33. So that is how much it increases. The wheel will increase, or it's this 3 is going on forever, so that's like 1/3 right there. So it's like 3 1/3, which you could write in there as the final answer, or you could rearrange this back into an improper fraction. So it's 3 times 3, which is 9 plus 1 would be 10/3 is another way, probably a more accurate way to write this answer, so we don't have to truncate that 3 continuing on forever. So, yep, our answer here is 10/3, or 3 1/3. 3 1/3 is a little harder to input there. All right, so that's the question 4. Next, they ask question 5, now write an equation for the height of the center of the wheel as a function of time in seconds. So it's for the center of the wheel. So the center of the wheel, it's going to start at 4 feet off the ground, and then it's going to go up basically the same as this height, just the equation of that line. So we could just write the equation of the line. If we assume it's going through 0, 0, then, so its y-intercept would be at 0, 0. So b would be 0, and all we'd have to do is figure out the slope. So the slope would be, and I keep wanting to, I keep looking at the 630 and thinking that it is like the horizontal, I keep thinking that it's the horizontal component here, but it's not. So maybe that's not, we could find this this side by using Pythagorean theorem, but I don't want to do that. I think it's just a little too time consuming. So I'm going to do this, or we could just say as well that we just figured out that, another way of doing it is we just figured out that as a result of going up the ramp, we see that it goes up by 10/3 per second. So it's going to have an initial height of 4 from question 3, and then we're going to be adding 10/3 per second. So that's the answer to this next one. It is 4 plus 10/3t. Yeah, I'm not sure if I'm going the right direction, and I said, okay, let's write the equation of this line, and then just add it. I haven't checked doing it that way, so let's just stick with what we've already spent time calculating. So, okay, so that's the answer to part 5. It's just our answer to 3, really, plus our answer to 4 times t. Okay. Next, it says write an equation for the height of the point P above the ground as a function of time in seconds. So now we're going from not just looking at the center and finding the equation for the center, but we want to also find the equation for this point P that will be rotating around the circle as we go up the ramp. So what we really just have to do is we have to find the equation for this movement of that point around the circle, and then we just add it to the equation that we have for the center of the circle already. So when we have a circle of radius 4 and the point is going to, it looks like it in the problem, the point starts at the top of your circle. And then I'm going to assume that it's going this way. So I'm assuming that the height is going to go down, hit its average, go to the very bottom again, and then it's going to increase in its height. So it looks like it's going to start at its max, which is probably 8, right off the bat, and then it's going to go, and it's going to travel this way, and it's going to go down, it's going to go down, hit its minimum, then travel back up to the top, and so at time 0. So this looks like it's a cosine function. So I'm going to say this is cosine. It's of the format A cosine BT plus K. Well, I'm really just focused on, we're not really worried, I would just say it's in the A cosine BT format, because I'm just, right now I'm just focusing on writing this point as a function of time, as it just goes around this circle. And then we'll worry about going up the ramp next. So because this is a radius of 4, we know that the point on a terminal side of a circle with radius 4, that it goes through a circle of radius 4, it's just 4 cosine. So our amplitude here is going to be 4, and that makes sense. If it's 4 here, then it's going to be going it's going to be going 4 above and 4 below a certain value. So that makes sense that from the average, which is happening here, the average height is happening there, down to its minimum, it's going to be going that distance from max to average value is 4. So it's our amplitude. Then the B here, we have to figure out the period, and to help us find what B is. But we have to make sure that our T is here in seconds. So we have to make sure that it makes sense that this B is going to be the period, but it's also going to be that the period in 1 second, so okay, well, wait, I'll restate that. Let's see. So we do have to make sure that when we multiply this by 1 second that it makes sense, because we're plugging in seconds here. So we need to know, we need to know how long it would take to do 1 full revolution. That's what we want for this B. That's what the period is. The period is the length of time that it takes to do 1 full revolution, not B, but the period. And if this is measured in time along this distance, which we want it to, because we want this equation to be in time, then we want our period to be in a length of time as opposed to like distance. I guess if they were asking us to write with the D, with H a function, so given a certain distance, give me the height of the point on this ball, then the period would be a distance. that it takes to do 1 full revolution. But we here, because the period, it's h of t and time is the value on the x-axis here, now we want length of time that it takes to do 1 full revolution. Okay, so we look back at our answers actually in the previous page, and they actually made us calculate this already. It says traveling at this speed, how long does it take the wheel to make 1 full revolution? So it's 8 pi over 7. So the period is 8 pi over 7. So I'm going to erase this. We don't need that so much either. So now I write the period is always equal also to 2 pi over b, and this is how we're going to go about finding our b. So the 8 pi over 7 is equal to 2 pi over b. And then I multiply both sides by b, so it would be b 8 pi over 7 is equal to 2 pi over b times b. These b's cancel on that side, and I get, b is b times 8 pi over 7 is equal to 2 pi. Now I can multiply both sides by the reciprocal of 8 pi over 7, which is 7 over 8 pi. So these are going to cancel, those are going to cancel. I'm just going to get b on this left-hand side of the equation, and then I get over here, the pi's are going to cancel, and then I divide by 2, it gives me 1, divide by 2 gives me 4. So b ends up being 7 over 4. So there is our equation. That's the equation for just the point on the circle rotating around, the point of rotating around the circle. That's our equation. The problem is not very clear on like which direction the point is actually moving, and I guess we might have to, but I guess you could, in a real life situation, you could fix it and they may tell you which direction they're going, and that might clarify things a little bit, but it may, and I'm not sure if it would change the equation or not. So that's a good question, but at this moment, we'll just assume that both equations would end up looking the same, whether you went to the left or to the right. The rotation was to the left or the right. Okay. So for cosine, okay, so that is just the movement, the point relative to the center moving around the circle. But now we also have to, so that gives us, that equation gives us, exactly where this point is, and it gives us the height on that point. At any moment as it's going up the ramp, and then all we have to do is add the height of this ramp, which would be one line there, And then now we will have the complete height of the point on the circle going up the ramp. So all we have to do is add the prior equation that we have up here, the 4 plus 10 over 3t, and there's our final equation, and for the equation for of the height of the point above the ground as a function of time t in seconds. All right, I hope you found this valuable. Bye. Let me just